that would speed up the sampling rate. The spacecraft's main engine is fueled by hydrazine and nitrogen tetroxide, which ignite spontaneously when mixed. The propellant and oxidizer are forced out by a bladder of expanding helium. As Juno was finishing its second orbit, the helium valves were not responding correctly, so it was decided to maintain the original orbit. A mission extension has been granted to allow for the longer orbits Juno continues to follow. Within a day of the helium valve problem, Juno went into safe mode. All instruments went offline and data was lost. It appeared to be similar to the difficulties experienced by Galileo, but engineers traced the issue to a data transfer problem from one specific instrument, and the spacecraft remains healthy. Jupiter's axis is tilted at only 3 degrees, making even an oblique view of the poles near impossible until Juno arrived. When viewed in the infrared, researchers saw a complex arrangement of storms at both the poles. At the North Pole, a central vortex is surrounded by 8 anticyclones. At the South Pole, 5 anticyclones surround the central storm. Scientists do not understand why the storms, all rotating in the same direction, do not obliterate each other. On its 7th close pass of Jupiter, Juno flew directly over the giant red spot. Its microwave radiometer was able to map the heat distributions at varying levels down to 350 kilometers. The red spot is a giant storm, and Juno was able to see much higher temperatures at the deepest levels they could penetrate. With no geographic features, as on Earth, there is nothing on Jupiter against which storms can dissipate. The Great Red Spot remains firmly 22 degrees below the equator, yet it appears to have drifted around the planet at least 10 times since reliable observations began. Jupiter's magnetosphere is huge. It traps charged particles in bands stretching out to vast distances. This gives sensitive electronics on orbiting spacecraft like Juno big problems. It was assumed that Jupiter's magnetosphere was generated, like Earth's, by dynamo action, the convective movement of an electrically conductive fluid deep within. So far, results from Juno suggest that this is not the case. The lumpy nature of Jupiter's magnetic field points to an atmospheric source. The giant auroras at the poles also seem to come from a different mechanism than